Yes, hi everyone. Good morning. All right, I'll just share my screen so that we can start. Yeah. So in the last session, yes, in the last session, we have seen, we have started with the nested queries, right?
Yes, sir.
Excuse me. Yeah. We have started with the nested queries. Now we are going to see CT, views, joins, this part, right? So, uh, just a minute, I'll just put a heading as CTs. Let us take this little below. Yeah. Okay. Just a minute. Yeah. So, what is city? I'll just put a scenario so that you can understand city in better sense. Suppose, imagine you are working as an analyst in large bank, right? Whatever we have seen till now is very basic or uh, is just a basics of SQL, or what we can say is a very naive approach to solve SQL queries or any question. Here we are going to start with some smart approaches. One is CTE, another is view, and then we have joins, right? So smart approaches means you will be able to minimize your time of query, or you'll be able to save your time to get the answer, save your efforts, save your code. Everything will be optimized, right? So just imagine you are working as an analyst in large bank, and let's say you are required to find top 10 clients, top 10 clients out of 1,000 clients. And of these clients, your company wants to give some cash handouts, Mm. Mm. cash handouts to the one that has least turnover in the current year. You can definitely use a simple query to achieve this, right? As we have discussed, you can definitely use a simple naive approach to achieve this by using minimum function uh, and where clause. But what if you want to derive multiple insights from this data of your top 10 clients, right? Suppose you got this output for top 10 clients. And what if you want to achieve some, if you want to derive multiple insights, let's say from this top 10 clients, who is the most common client or something like that. Most you want to derive multiple insights, right? You want to use this code multiple times in simple words of the top 10 client. So in this case, it is always better to use common table expression, CTs. Always better to use CT so that you can get an idea uh, of only those client and perform all of your analysis on a subset of your data. You can perform all of your analysis on subset of your data, right? subset of your entire data. So we'll be learning about the CT. So what the CT will do? It is a query that you guys will write that will give you some, for an example, top 10 clients uh, in this table, so that you can derive insights from that, right? So every time you don't need to write down this code. What you'll do is you'll save this. There's a keyword with let's say top 10 client, top 10 clients with top 10 clients. So you'll write down this and you'll write down the query, and then you'll not end this statement. You'll not end, and you will write down select star from this query, top 10 clients, right? That is what we have. Now, I think you guys will get an idea about this if we see it in SQL, right? So everyone open your SQL and just load your data. Just load your data. Now, this is a little okay. I'll disclose this after some time. Uh, Before if I disclose, so that okay. Uh, Now what we'll do is we are going to perform the query by using your city, right? We'll use city for that. So uh, let me just run this code so that we can get an output, right? I'll run this. Okay, use market star schema, unknown database, create. Okay, so I have run this query successfully. Now let us take some questions to understand the CTE first, right? Even though we only have solved three questions, is it? In the name of most okay, we'll solve one more question for nested query. But before that, let us understand CT. So what is CT? CT as it is described, as we have discussed. CT is nothing but we are taking a subset of the query, right? Subset of your data basically. And that data, that subset of your data will be somewhat useful that we are going to use after some, we are going to use frequently, right? So uh, the first question that we can have is find the 5 products which resulted in the list losses, right? You have to find 5 products which resulted in the list losses. And in that product, you need to find out which product had the highest product base. highest product base margin among those. Right? Now, what we'll do is, obviously, you can approach this problem by using simple queries, very simple queries. You'll write down select product underscore ID, comma profit, comma product base margin, product underscore base underscore margin, right? From which table? So from market fact full table, right? Where where your profit is less than zero, and you're going to order by which column? Profit column in descending fashion. You're going to limit that with 5, right? You're going to limit that with 5. So selecting product ID, profit, product base margin, where profit is less than zero means loss. And in that, we want to limit this with 5, right? So these are the 5 product which resulted in list losses. And for that product, we are finding the product base margin, right? So product 6 has highest product base margin. Then uh, then product 16, then 6, like that, right? So what if I tell you, this is simple query, no need for CTE, but what if I tell you I can create a dummy table, temporary table, right? Which gets vanished, temporary table. So with list losses, I'm going to select same query, basically. I'm just renaming this query as list losses. The keyword is with, right? Keyword is with. And let us have some beautification of this query. Uh, we'll close this, but we'll not put a end to this, that is semicolon. We'll not put end. Then we'll write down select star from which table? From list underscore losses that you have created. And where your product base margin is equals to selecting maximum of product base margin from list underscore losses, right? And you're going to close this. So if you run this, from this list losses, you are going to get the maximum of you are going to get the product ID, which has the product highest product base margin. As this query tells you, what is the maximum? It is 0.78 is the maximum, right? 0.78 is the maximum. So we are just putting CT for that. And how do you create CT? You write down with the name of this table, temporary table, right? You write down this. So that is how you create CT. I hope this is clear now. Just give me a quick confirmation if it is clear. Then we'll go to the next part, that is second part. Yes, everyone, is it clear? Okay, write down this now. I'll give you 2 minutes. Yes, is it clear? Is it done, everyone? All right. Now, there is one problem with common table expression. What happens is, uh, suppose if you just close this query, right? If you just close this query, and let's say you want to find some insights from the list table that you have created, that is a common table expression, you'll not be able to find anything. It will throw the error. Just try this. Once the query is executed, there it will give you the error. It says that table market star schema list losses does not exist. What does it means is I can use this particular name, that is list losses, wherever I can use a table name, where all I can use it is a table name inside this query itself, right? Once I come outside of this, it is not possible. So it gets vanished, right? So which means that the table is allowed. You can do whatever you want to do inside this query itself at the time of defining this particular common table expression, right? Once you come outside, it will not be there. So it's a temporary table. This table is a temporary table. Temporary table. So you'll ask why we should write down this. We can directly write down the query. So we have one nice other mechanism which is known as the views, right? Views, once it is created, unless and until you don't delete that or drop that, view is also something known as something similar to this, but it is more advanced in the sense that you can use view outside your query as well, anywhere. Unless and until you don't drop, you don't delete that, it will always be there in your query. You have to drop your view basically, right? So it's not a temporary table, it's a permanent table in other case, right? So before that, we'll just take one quick example to understand views, sorry, CTs in more detailed manner. So second question is, you need to find all low priority orders made in the month of April, and out of them, how many were made in the first half? In the first half of the particular month. So you are going to select order ID, order date, order priority from orders underscore dimension table, where order underscore priority is equals to, it should be low, first of all, and So the question is, you want to find all low priority order, right? In the month of April. So can I say April is fourth of the month, fourth of the year, or can I write down April as four? Because in our order dimension table, select star from orders underscore dimension. We don't have a text like April, March, right? It is a 3, 10, 8, 4, 65, right? So it's in DDMMYY format, or it is YYMMDD, right? So April is 4, right? In this thing, April is 4. So this is April, and if you just scroll down, you will be able to get April. This is April data, right? So you want to find low priority order, where order priority is low, and I'm introducing another date function, which is month. Month of which column? Month of order date, order underscore date. That should be that should be exactly equals to 4. That should be exactly equals to 4. So if you run this, you're going to get the output for that, where you're selecting order ID, order date, order priority, where order priority is low and order date is 4. That is, month of order date is 4, right? Month of order date is 4. So that is what we have. Is it clear now, everyone?
Yes, sir.
So write down this. All right. Now, what we'll do is we will create a city for this, right? So here we are only getting in the month of April, but out of them, how many were made in the first half of the month? This question we are not able to solve, right? How many were made in the first half of the month? Means from 1st of April to 15th of April, right? 1st of April to 15th of April. So let us create a city for that. Let us rename this as low priority priority orders as, and let us quickly copy this query. Let us take it over here. Um, Let us finish it, and then we are going to select. We are going to select. This is not required, so we are getting the error for that. We are going to select uh, count of order ID first of all, because what they're asking is from this low priority table, from this low priority orders table, I want to find the order which is placed in the first of the month. So where day of order, day of order date, it should be in between. So I'm introducing another keyword, between. It should be between which date? Date should be between day of order date. So it will extract the day. We have suppose this example 2009 4 26. So this is day, right? This is month, and this is year. And the column name is order date. So if you write down day of order date, if you write down day of order date, what you're going to get is you're going to get day, this day, right? So day should be in between. Between spelling is wrong. So that's why it is throwing error. Between 1 and 15. So if you just run this, the out of them, how many were made in the first half? So it is 46. 46 orders are made in the first half of this month, right? Simple. So that is what we have. Now, just now we have discussed, like, can I use this low priority order after once the query is completed? Obviously, I cannot do that, right? If I want, select all the records from low priority order table, which is a temporary table. Can I use this query outside of this? It shows it does not exist. So the solution is create a view, right? Now, how do we create a view? Let us see that. So let's add one question, create a view to display the sales amount, sales amounts, the number of orders, profits made, and the shipping cost of all orders. I need to query this, query it to return all orders which have profit of greater than 1000, right? So let us create a view. Create view. View name is order underscore info as, now you'll write down a code. So what do you want? You want to select sales amount, number of orders, profits made, right? So you'll select order underscore ID first, sales column, order underscore quantity, profit, shipping cost, shipping underscore cost. From which table? From market fact full table. Simple. And if you write down this, if you just check, the view is created, right? And can you see I'm closing this query? It does not mean that I cannot use it afterward. I can use, the view name is order info. The view name is order info, right? So what we'll do is we'll select order underscore ID, comma profit. From where? From order underscore info, where profit is greater than 1000. Where profit is greater than 1000. So you will copy this and you'll paste it over here. So in this view, which we have created, which is order info, it will act as a table now, permanent table, the order info. In which what do we have? We have order ID, we have sales, we have order quantity, we have profit and shipping cost. But we are only selecting order ID and profit from that, right? Because we want number of orders and profit, right? Is it clear? Where profit is greater than 1000. Query to return all the orders which have profit greater than 1000. Profit greater than 1000. So obviously you can select star. Suppose you want to check what is there in order info. So you can check just like your table, select star from order info, and you're going to get the output for that, wherein you will get order ID, sales, order quantity, profit, and shipping cost. Yes or no? Right? Is it clear? So that is how you create a view. Cholo, let's do one more question. Let us do one more question. Which year generated the highest profit column? So you're going to create a view, market facts and orders as select star from market fact full table. Uh, okay, so basically we have two table, right? Order dimension and market factual. I'll just show you how do you join this, right? Because if you just see order dimension table and select star from market fact full table, if I just run this query, because what get, I want to get which year has generated the highest profit, right? Year. But in my market factful table, I have year nowhere in this table, right? Can I have year? Can I extract year? I cannot extract because I don't have year over here. So I have to associate this table with the order dimension because which year generated the highest profit. So I have order ID, I have order date. I can establish a connection between this order ID and this order ID of this table because order ID are common, right? Order IDs are common. This is order ID and this is order ID. So based on the order ID column, we can join this two table, order dimension and market factor. If we are able to establish a connection between these two table, we can easily relate order date from order dimension table and profit, right? Highest profit from the market factual table. So let us do the join. I'm going to create a view in which the view name is market facts and order, selecting star from market factual table. So I want all the records from the market factual table. I'll establish an inner join connection between orders dimension table and using which common column? What is your common column between these two table? Order underscore ID, right? Because order ID is common for all the tables. All means two table. If I do this, if I run this, I'm going to get the output. And if I just check, select star from which table, the table name is market facts and orders. If I do this, if I just run this query, particular query, I'm going to get connection wherein I have order ID as well, I have profit as well, I have order date as well. Now I can easily find the answer for this question. Yes or no? I can easily find which year generated highest profit. Profit I have, order date I have. So that is how you establish a connection, right? That is how you do the join. Now, what I want is year generated the highest profit. So here, obviously, uh, can you see one? We have order ID 5446, 5446 two times. Similarly, 5446 here three times. So basically, we are interested, or we need to take a sum of this profit, right? Because same order ID has three orders. Yes or no? First order has profit minus 30. Second has 1148. Third has 47.64. So I have to make sum of this profit, right? I have to take sum of this profit. So I'm going to select sum of this profit as year-wise profit. I'm renaming this as year-wise profit. I'll establish, I'll select order date year, because the question is which year generated the highest profit. So order date year as order underscore year, and from market underscore facts underscore and underscore orders, which is a view that we have created. From that view, I'm going to group by based on the order underscore year, this one that we have created, and order by which year wise profit. So I can copy this. I can paste it over here. I want to order it by year wise profit, right? Because we want highest, not lowest. We want highest profit. So by default, it is ascending. So we should write descending for that, because we know by default we get ascending. We need to write down descending. And what do we want? Do we want top three orders or only one order? So only highest profit. So one, limit with one. If I run this, can you see 2010 has the highest profit. So 2010 year generated the highest profit of this particular uh, data or this order. Is it clear now, everyone? Anybody have any questions in this? Just give me a quick confirmation, guys, so that I should move to the next part. Is it clear, everyone? I only see three responses. What about other guys? Four. Is it clear, everyone? Excellent, excellent. Now I can see more responses. What I'll do is now, let me have 5 minutes of break only, please. I'll have my coffee. Meanwhile, till this time, you will just solve this question, right? So if it is not, if this is not done, you can take this out. I'll paste it in the chat, but you'll not be able to copy that. You can write down from the chat. This is first question, and second question I can show you, because the screen is being, we cannot show maximum part of the screen, so it is restricted. Second I can show. So second question is which year generated the profit. I'll just take that out in the chat, and this is your answer for that, right? So you can write down this. Just give me 5 minutes. It's 9:51. I'll be back by 9:57. Okay. So that is what we have for view. Now let us have a discussion on join, right? How do we do a join operation, joining operation? So there are basically two or three types of join major. One is inner, then outer, and then okay, just let me take joins here. '25 bold, right? Now, uh, so we have inner join, we have outer join, inner join, outer join. Uh, so basically, suppose you have this two table, right? You have two table, or let me take table over here only. Suppose we have products table, we have product ID, product name, and quantity, right? Here also we have product ID, we have profit, and we have sales, suppose. So let us take one more product on here. So product name. So these are the two tables that we have, right? This is one, this is two. Now, if you do the inner join, it will take common records between these two tables, only common records, this portion, right? Means only product ID and product name, product ID and product name. So in the output, you are going to get only two columns wherein you will be having product ID and product name, right? If you take outer join, if you take outer join, you'll be getting all the records. Means if you do outer join between these two table, product and let's say ABC table, you are going to get 1, 2, 3, 4, 4, 5, 6. How many unique are there? Product ID, profit, quantity, 3, 4, and 5. 5 will be there. All the records will be there, right? This is your inner join and outer join. And then you have left join and right join. As the name suggests, left join means as it is left join, you will be getting all the records between the left table, all the record between the left tables, and common record between the right table, right? So basically all the record between the left table you are going to get. All the record from the left table, common record from the right table. That is your left join. And right join is opposite to that. All the records from the right table and common records from the left table, left and right table, right? So that is your left and right join. This is right join, this is left join. So only difference is now how you'll ask how to understand which is left table, which is right table. It's simple. While doing joining on P dot suppose product ID, if you write is equals to M dot product ID, because suppose product ID is only common column over here. Imagine. So first what you are writing, which table you are writing first, that will be your left table, right? The table name that you give first is your left. Table name that you give as a last is your last table. So suppose P is first table, M is second table. As you're writing P as first, so it will be at left position. M will be at last position, right? P will be at first, M will be at last because P we are using first. If I write M dot product ID is equals to P dot product ID, so M will be first and M will be left table. Simple. Is it clear now, everyone? How to do the join operation? Now let us understand this. So I'll just put heading as sessions. joins and set operations. Joins and set operations. Here we are going to see inner join, and I'm going to print the question is print the product categories and subcategories along with the profits made for each other. Sorry, each order, not other. I want to print the product categories and subcategories along with the profits made by each order, right? So I'll select order underscore ID, comma, product underscore category, product underscore category, product underscore subcategory, product underscore sub underscore category, profit column. From which table? From product underscore dimension table. And I'm just renaming this product underscore dimension table as P, right? So if you are wondering what is this P is all about, it's just a name that we are giving for product dimension table, right? So product dimension table is P. Just imagine, just consider. And I want to do the inner join on market factful table. I'm renaming this as M. Why there is need of uh, join operation? Let us try to understand that. Select product dimension, select star from market factful table. Now, why there is a need of joining operation? Why there is a need of join operation? Why there is a need of join operation? So, if you just see, we want product categories and product subcategories. Product categories and product subcategories, which is there in your product dimension table, along with profits made for each order. Profit is in market factful table. So common column is order ID between these two. Product ID, sorry. Product ID is common column. So we'll do the inner join uh, market factful table as M, and on you need to write them on P dot product underscore ID is equals to M dot product underscore ID, right? If you run this, you are going to get order ID, product category, product subcategory, and profit for each order ID, right? So if you see one thing, even though your product ID column, let's say your product ID column is this P capital and I is not capital, but there is no any problem, right? It is not a case sensitive, right? I can use this. I can write on product underscore ID as capital because it is not a case sensitive language, right? There is no any problem of writing down this. So second point I have told you. So that is how you do join. Select from, we write down the name of the joint and on which common column you need to write. Now as P we have written first, P. P is which table? P is my which table?
Product dimension tables.
Very good. Read product dimension, right? So that is your left table. And this will be your right table. Market factful table. Right? Simple. So you can revise this. Let us not waste our time. Let us go to next question for join operation. You need to find the shipment mode from a profit made and product category for each product. Shipment mode, profit made, and product category for each product. So shipment mode is, I think, is it again we need to do a join operation because we have to do join on three column here. Three. Let us see which are these three table. Select star from shipping dimension. Underscore dimension. Okay. This. Now, if you see, we have these three tables, right? What is your question? You want to find shipment mode. Shipment mode is in your is in my shipping dimension. Yes or no? Profit made. Profit is in my market factful table. And product category. It is in my product dimension table. So let us check common column is what? Which is your common column? We have product ID. We have product ID over here. We don't have product ID over here. So I can create a join based on product ID of this product dimension table and product ID of market factful table. And here, do we have any common column? Shipping ID, yes. So once this two joins, once these two tables are joined, I can do join on which common column? Shipping ID, because shipping ID is in my market factful table. Shipping dimension is also in my market factful table. Sorry, other table, which is that shipping dimension. So ship ID here, common column, product ID here, and product ID here, common column. So there is no any need of having three common column. So it's just like your property. You can join A and B first, and then we can join B and C, right? So A and B has common column. B and C also has common column. Then we can establish a connection between this, right? So let us solve this question now. Selecting P dot product ID, profit, product underscore category, ship mode, from which table? Product underscore dimension table. We are going to do inner join on market fact full table on P dot product underscore ID is equals to M dot product underscore ID. We are going to do inner join on shipping underscore dimension table on M dot ship underscore ID is equals to S dot ship underscore ID. Right? So as we have discussed, we are going to get the output for that. So product ID, profit, product subcategory, and shipping mode. Simple. That is the second question. Third question is a little simple. Let us try to find the shipment date, comma, mode, and profit made for every single order. Select order underscore ID, profit, ship underscore mode from market fact full table. You are going to do inner join on shipping underscore dimension S on m dot ship underscore id is equals to s dot ship underscore id, right? So if you run this, you are going to find the shipment date, mode, and profit made for every single order, right? Shipment date, shipment mode, and profit. So shipment date and shipment mode is in your shipping dimension table, and profit is in your market factual table. Common column is shipping ID, as we have discussed, right? Then let us have last question for joins today. Which customer ordered most number of products? Which customer ordered most number of product, right? So, uh, most number of product will require market factful table and will require all the three tables. I think, yes, these three tables are needed. I'll explain why these three tables are required, right? So if I just execute this, what do we want? We want customer who ordered most number of product, right? So from market factful table, from market factful table, we'll get the order quantity, right? Most number of product means order quantity. Ordered most number of product. That is something which we are going to get by market factful table. But which customer? You want customer name. Customer name is in your uh customer name is in your customer dimension. Sorry. So we'll require customer dimension table as well. And there's no any need of product dimension, I think. Yeah, no need of this. Only two tables are sufficient. Order quantity is in your market factual table, and customer name is in your customer dimension table, right? So simple now. How do we do that? What do we want? Which customer order most number of product? So we'll write on select customer name I want. That is first thing. Sum of order quantity, because as you have seen, we have same order ID for multiple orders, right? Same order ID for multiple orders. So order quantity for 5446, this is 23. 5446 is 26. Again, somewhere we have 5446, that is 23. So we want to get some of this order quantity based on the order ID, right? So इसको नाम देते हैं. Let's rename this as total underscore orders. And from which table? From customer underscore dimension table. I'm going to do inner join on market factful table. Let's rename this as M on C dot customer underscore ID is equals to M dot customer underscore ID, right? And you can do group by based on customer name column and order by total underscore orders in descending fashion, right? So if you do this, you are going to get the output for that. So customer name and total orders are 222 and 166, 168 placed by these two customers, Aaron Hawkins and Aaron Bergman. So which customer ordered most number of product? It is these two customers. Is this thing clear now, everyone? Yes, you can revise this because we are lagging too much. We need to pick up some pace and we need to cover a skill quickly. So you can watch a recording, you'll understand this. I have explained it multiple times. Anyway, I'll not give you I cannot give you time for practice. You can do that thing after as part of your homework. Right? Now, next question. Selling office supplies was more profitable in Delhi as compared to Patna. Is it true or false? Let us check this. So this is real-time questions. You can consider this as real-time questions, right? Very easy. So selling office supplies was more profitable in Delhi as compared to Patna. True or false? How will you do this? Yes. How can we do this? So let us see how can we do this. What do we want? Selling office supplies was more profitable in Delhi as compared to Patna. So we'll require one, two, three tables will require, because if you see, we will need product dimension, customer dimension, and market factual table. So I'll just take that. So let's start from product underscore dimension, right? So if I just take this, I have market factual table, which is okay, office supplies and Delhi. That is in my customer dimension table, right? City is in my customer dimension table. Customer segment, that is office supplies, that is also in my customer segment, that is my customer dimension table. But selling is associated with market factual table, because from sales we have it in market factual table, and uh, product dimension is your product category. So yeah, city is in customer dimension, office supplies, that is product category, is in your product dimension table, and sales is in your market factual table. So how do we establish a connection? Customer ID, common column between market factual and customer dimension table, and product ID is common between market factual and product dimension. So this two table has product ID common, and this two table has customer ID common, right? So let us do that. Let us join these three tables. So what I'm going to do is I'm going to write down, select, I want city, I want sum of profit as city-wise profit. Let's rename this column as city-wise profit. From which table? From product dimension table. I can do inner join on market factual table. Let's call it as M on This product dimension and market factful table. Product dimension and market factful. Which common column? Product ID. Product ID, right? So on which table? P dot product ID is equals to M dot product ID, right? P dot product ID and M dot product ID. Then you're going to do inner join on customer underscore dimension table. Customer underscore dimension table. Let's rename this as C. Now customer dimension and market factful table. Customer ID is common column, right? So on M dot customer ID is equals to C dot customer ID, right? And where product category should be office supplies. That is our condition in the question. So we'll write down office supplies here and city, city uh in two city you want, right? Delhi, and you want to compare Delhi with Patna. So that is what you will do. And let us group by with city column. Let us group by this with the city columns. So if I just take this, if I just run this, okay, unknown error, where clause, category, category, yeah. So that is what we have for the city-wise profit. Don't we have Patna? Is it? Let me check. City is P Q R S T. I think Patna is not there, but you can compare, let's say, then Delhi with some other city. Let us take, okay, customer dimension. No? Let me just add values to customer dimension table. This is your customer dimension. This. Mm, Okay, we need to drop that first. Okay, anyway, in our customer dimension table, let us compare the other two cities. We have we have Kolkata. We have this, right? So let us take this Calcutta. And so if you compare this to city-wise profit for office supplies, which is higher, Delhi. You can compare with another city, let's say Bangalore, right? If I just take this, city-wise profit is high for Bangalore now, for which office supplies. So that is how you compare, right? And next question we can have is sixth question. You need to print the name of the customer with the maximum number of orders. So you are going to select customer name, sum of order quantity, as number of orders. Let's rename this as number of orders, right? And what do you want? Print the name of the customer with maximum number of orders. So you need to establish a connection between market factful table and customer dimension, because customer dimension and market factful table, customer dimension has customer name, market factful has number of orders, that is order quantity. So you want to name of the customer, right? So this two table, common column is customer ID. Customer ID is common column. Let us do the join. So I want customer name, sum of order quantity as number of orders from which table? Customer dimension table. Let's rename this as C. I'll do inner join on market factful table as M. And on which common column? Customer ID between these two table. Customer dimension, customer ID of this is equals to M dot customer ID. And I'm going to group this by customer name and order it by number of orders in descending fashion. And limit this with 1. Right? Limit this with 1. If I just run this, I'm going to get the output for that. Is it fine, everyone? So name of the customer with the maximum number of orders is Aaron Hawkins, which we already have discussed earlier. This query we have solved earlier, right? Is it clear? And then I want to print the 3 most common products. I'm going to select product underscore sub underscore category. I'm going to select order underscore quantity from product underscore dimension P. I'm going to do inner join on market fact full table as M, and on P dot product underscore ID is equals to M dot product underscore ID. And I'm going to do group by on product underscore sub underscore category. I'm going to order it by order underscore quantity in descending fashion. And I'm going to limit this with 3, right? So if I just take this, okay, it is in market factful, okay, here it is. So 3 most common product. If I just select this, I'm going to get the output for that. Syntax error. Yes. 3 most common product. Select. Okay, let us check product underscore dimension table. Select star from market fact full table. Right? Let us take this. So in this two table, do we have product ID common? Here I have product ID, here I have product ID. So from market factful table,
Sir, you forgot to mention on.
no, M is remaining M because I have not mentioned M, no? Market factful table should be M. And then here on is there, right? So if we need to mention which is M table, right? It was getting confused, which is your M table. Now it will work. Yes. So three most common product are appliances, paper, and office supplies. There is a tie between appliances and paper. Now, is this thing clear to you, everyone? Can I get quick confirmation about this? Okay, you write down this. Let us have a break for 7 minutes now. And after the break, we are going to move further with the advanced SQL part. So it is 10:37. Let us have a break for 7 minutes. We'll be starting advanced SQL part exactly at 10:45, right? So you do this, and if you have any questions, just write down in the chat. Just let me know. We'll discuss that after the break, right? All right. So now let us move to the next part, that is advanced SQL, right? So in this thing, I'll just be giving you a quick introduction because we don't have sufficient time. We'll be in a position to finish SQL and advanced SQL, this module, by tomorrow's session, right? So what I'll do is I'll quickly create new tab. Let us create a new tab. Let us rename this as advanced SQL. And in this, we are going to understand the window functions first, right? So in Windows function, we will discuss rank and dense rank. The questions that you guys had in the last quiz, right? So let us solve. Let us understand this. So, for very first thing, what is window function, right? So for an example, why there is need of Windows function? Very first, in the previous module, very basic SQL, you learn about databases and their various constituents. You also understood the steps involved in designing database, which are as follows. Like you ideate and design ERD, you add a database schema into its various table, the values in each table and the constraint. And then you query a database using several SQL statements to extract valuable insights from the data, right? So far, you have covered all the basic concepts of SQL. However, you should be aware about some advanced concepts of SQL, such as window functions, query optimization, case statements, stored functions, and cursor, right? So these are the useful tools for handling several use cases and will help you to solve complex questions easily, right? Now, in the previous module, you learned how to order employees by their salary. It's an example in the example data set. One method is we have seen how do you order the employees by their salary, right? In the previous module. One method to this would be to categorize them by their values. For example, you can divide them into the following criteria or categories. First is employees earning less than 2.5 lakhs, and second is employees earning greater than or equal to 2.5 lakhs per year, right? You can categorize this into two criteria. Now, first category of the employees will not be having uh, they don't have to pay taxes. For an example, they need not to go through some of the additional checks for the tax criteria. But let's say we have a tax slab where employees earning more than 2.5 lakh needs to pay the taxes, right? So these no taxes here, pay tax, right? So you have to check the additional check for the second category of the employees that will be required to go through. And you can solve the problem statement using a filter condition in a where clause. Now imagine you are working in a bank and need to identify your customers on the following criteria. First is top 10 percentage of customers, that is platinum. Second is next 10 percentage of customers. You want to categorize them as gold. Then next 20% of the customer, you want to categorize them as silver. And further rest of the customers, that will be regular customers, right? So your bank wanted to roll out different schemes for these classes of customers in exchange of their loyalty. But how do you solve such a seemingly complex problem statement, right? You'll find answer in the window functions for that. So in this session, you will be introduced to a window function, concept of windowing functions. You'll learn about over clause and partition clause, and that is used to implement windowing. And after going through this session, you should be able to use window functions such as rank, dense rank, and percent rank. Three types of rank, right? So that is what we have. Now, what we'll do is, before actually moving further with the window function, let us touch another topic and let us stop here for the day because we do not have time as well. So the query part of window and partition and over clause, we'll do it. We'll see this in tomorrow's session. But let us discuss rank. Let us discuss rank. Why there is need of rank functions, so that you guys feel confident about the rank function, right? And in tomorrow's session, let us come back and see the above partition and window function over at that particular time. Now, for an example, rank function is nothing but, I'll just tell you a syntax to write down rank function. Then you can rank, you need to write down over which you need to do a partition. So you'll write down partition by. Here you will be having expression like uh, for which column you need to find the rank. So let us add it as expression. That is a query that you are going to write, right? And there will be multiple expressions, so you can write down this. And last but not the least, you'll use order by clause. Again, one query, that is expression, and order it by in ascending or descending. You can specify this, ascending or descending. You can specify this, and further you'll add an expression. So that is a simple and very basic syntax for rank. How do you do rank? You write down rank over, partition by, and order by, right? Now, uh, see, rank, what it does is, suppose you have two quantities, or let's say you have marks scored by student and name, right? Name one, name A, name B, name C. Marks are 99, 98, 95, and D is again 95, right? So rank is, let's say we don't have D for simplicity. Let's say you don't have D. So rank is 1, 2, 3. So very functional. Rank function is very, it is working fine over here. But what if I have, just a minute. What is this? What if I have uh marks as 99, 97, again 97, again 97, and then 95. So rank function, what it does is it simply calculates the rank, right? So it will be 1, 2, 3, 4, 5. That's all. But if you see, there is a tie between these two. So rank actually should be 2. So it should be 1, 2, and 3. Yes or no? So rank will fail at this point of time if there is a tie between this. So that's why you need to have a dense rank. You need to have a dense rank. So there are three types of rank, to be honest. One is rank, another is dense rank, and then there is a percent rank, right? Rank, what it does is it rank the current row within its partition with gaps Dense rank, what it does is it gives you rank of the current row within its partition without gaps. And percent rank, which is always between 0 and 1. That is a percentage, right? So there are three types of rank. Now, just consider, as I've explained, but I'll tell you one more scenario, same scenario. Rank function need not have consecutive values, but dense rank must have these values. For example, consider table. It contains marks obtained by top 3 students in the 12th board exams, right? Conducted by CBSE board, for example. So let's say we have name, we have marks, we have rank, and we have dense rank. So marks is out of 500, let's say. So there is a student whose name is, let's say, Shubham. Then we have Paritosh, and we have the Dilip. So marks is 495, 495, 492. But rank, what it will do is it will be 1. Here also it will be 1, and here it will be 3. Right? Rank. If you use rank function, the query will be like this, or the output will be like this. This is fine, 1, 1, but this is not 3, right? It should be 2. So your rank function will not give you consecutive values if there is a tie. If there is a tie, it will not give you the consecutive values. But dense rank will give you consecutive values. Dense rank will give you consecutive values. So it will be 1, it will be 1, and it will be 2. 1, 1, 2. Right? So this is because rank increases whenever previous entries have similar values. Now imagine if we have 10 students, if we have 10 students, instead of 2, instead of 2, 10 लोगों का मतलब 10 student has 495 marks, right? So if there is 11th entry, for an example, let's say we have here one student, then another student, another student, another student, another. Instead of 495, here we have 495, 495, again 495, 495, 495, 495, 495, and then 492. So as obvious, this student will be having 1 rank. But what about this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it 10? It's not 10, right? So your rank will give you 10 as this for this student F. Let's say DF. For this student, the rank is 10. But it should be 2, right? So there will be a problem. That's what we have for the rank function. And there is another fourth type of rank function, that is your row number, that you will learn about in the tomorrow session. So that is why the rank is needed. So as I've explained, this is your syntax for the rank. And yeah, that is what we have for the rank. Yes. So everything related to rank, its query part, that will be discussed. We are going to discuss after in tomorrow's session, right? So I'm going to share you one PPT on your drive. You can have a look at that, and you can uh, revise your rank function, right? Okay. All right, then we'll stop here for the day. If you have any questions, you can ask. Otherwise, we'll just wind up. So remember, the syntax is always rank over partition by and then order by. Rank over partition by and then order by. That is the syntax. Is it clear now, everyone? Anybody have any questions till now? Yes. Can I get responses in the chat? Right. So in tomorrow's session, we'll be actually having a look at this rank functions, and then we'll solve one case study quickly. So there will be a mini project before going to the next module, right? There will be a case study at the end of the session. So let me check if we have any quiz or not. Okay. I think we don't have a quiz session. We'll stop here for the day. I'm waiting for your questions if you have any. When I'm trying to create a table, it's skill developer compiler throws an error says, but when I'm running the same in an online compiler, gosh, what can I do to rectify this? Okay, can you share your screen, Darshini?
Yes.
Just you need to modify the settings. Like it gives you warning. You just need to modify the setting. Share your screen.
Can you look at my screen now, sir?
Yeah. Is it Oracle? Okay.
Yes, sir.
Mm, run this. What is that error? Scroll up, scroll up. Error part. Key error order number index. Error starting at line number 45 in command. Error is invalid character. Okay. Can you just show me the code? Ah. Mm, yeah, remove that key, no? It is not needed. Remove that key. Remove everything. Line. Not that. That particular line where you had key, remove that. Now it will work. Start again. Scroll up, scroll up, scroll up. Error. Okay. Scroll. Close this. Show that error code. It should be order dimension, order ID, varchar, integer 11. Remove that integer 11. Remove bracket. And you can remove not null and that constant as well. Like all the constraints should not be there. Not null for all the columns out there. This is order dimension table, right? Let me check.
Yes.
See, basically this code that we have is little earlier. Nowadays they have it has become obsolete. There is no any need to write down the not null and that kind of thing.
Okay, sir.
Orders dimension. Okay. For me, it is getting. I'm not sure why you're not.
Yes, sir. Even in online compiler, I'm also getting the same thing, sir. I'm also getting the output, but here I cannot get the outputs.
One reason might be this is Oracle, right? So they have
Yes,
other
sir.
uh, naming convention. It's a
Okay,
it
sir.
check Oracle identifier naming convention. If you are attempting to provide a password in this by clause, it is recommended to always enclose the password in double quotation marks. So basically, as I told, all the compilers are same,
Yes,
but
sir.
5 to 10% of difference between their syntax or their
Okay.
documentation or their manual or there are rules, basically the rules that we need to follow to write down code. So I personally have not worked in this Oracle. I'll not be able.
Okay, sir.
I don't have any idea. But if you just search error, you'll get answer for this. If you are not getting this, just try to install MS SQL. That is also very convenient. If
Okay,
my
sir.
and anyway, you don't need to worry. Like this is not that uh, what you can say difficult error. It is very simple error. Your query is correct. You're understanding what you're writing. That is more important, right?
Yes, sir. Okay, sir.
So don't worry. If you are getting error over here, you will not be getting error in MS SQL or online compiler.
Okay, sir. I'll try downloading MS SQL and all that.
Yeah, yeah, sure.
Okay, sir. Thank you, sir. Can I stop sharing my screen, sir?
Yes, yes.
Thank you, sir.
Yes, no problem. Yes, what about other guys? Anybody have any doubts, questions? Okay, then all right. We'll stop here for the day, right? And in tomorrow's session, we'll conclude this SQL module. Chalo. Thank you then, everyone. Happy learning. Bye.